Assalamu alaikum dear students. In today's physics class, we will discuss the long question number 1 to 5 from Unit 3 Dynamics 1 Part 1 of Class 9 Physics. We will explain each answer in detail so you can understand the concepts of force, motion and Newton's laws clearly, not just for exam but for the real understanding. So let's begin. Question number 1 is state the first law of motion and explain with examples. Why is it called law of inertia? First we have to give the statement of first law of motion, then we have to explain with examples, and then why is it called law of inertia. Newton's first law of motion is also known as a law of inertia. Why is it so? The statement of Newton's first law of motion is a body remains at rest or continues to move in a straight line with constant speed unless acted upon by an external force. This tells us that things don't stop moving, or change direction by themselves. An external force like push, pull or friction is needed to make any change in motion. If no force acts, the object will just keep doing what it's already doing, resting or moving. Explanation: this laws mean that an object cannot change its state of motion by itself. If it is rest, it stays at rest. If it is moving, it keeps moving at the same speed or in the same direction unless a force such as friction or push or pull change that state. Examples: a book on a table will remain there until someone pushes it. अगर हम उस बुक को if no one touched that, it will stay there forever. You have to push it to make it move. Example number 2: a moving football will keep rolling unless friction or another player stops it. On grass, the ball stops after some time because friction acts on it. On smooth ice, it will roll much further because there is less friction. Okay, why is it is called the law of inertia? Inertia is the natural tendency of an object to resist any change in its state of motion or rest. Newton's first law explains exactly this property, which states that without any external force, an object will keep doing what it's already doing. Since the law is based entirely on this idea, it is also called the law of inertia. Inertia means natural tendency of an object to resist any change in its motion or state. मतलब inertia एक natural tendency of objects है जिससे ये रेजिस्ट करता है. अगर मोशन में है तो रेजिस्ट करेगा, रुकेगा नहीं विदाउट एनी एक्सटर्नल फोर्स. अगर रेस्ट पे है तो मूव नहीं करेगा विदाउट इन द इन्वॉल्वमेंट ऑफ एन एक्सटर्नल फोर्स. Means and first law is all about this idea. It says if nothing disturbs it, an object will keep doing exactly what it is doing. Question number 2 is define inertia. Why is it important to have knowledge of inertia in our daily life? Elaborate your answer with example. Here we have to define the inertia, and we have to discuss why the information, the knowledge of inertia is required for us in our daily life, and we have to give examples of daily life as well. Inertia is the natural tendency of an object to resist or change any change in its state of rest or motion. The greater the mass of an object, the greater its inertia. Inertia वही किसी भी ऑब्जेक्ट की वो टेंडेंसी है, वो सलाहियत है जिसमें जब तक कोई एक्सटर्नल फोर्स ना लगाए जाए, अगर वो मूव कर रहा है तो वो मूव करता रहेगा उसी स्पीड से, अगर वो रुकेगा नहीं विदाउट एन एक्सटर्नल फोर्स, जिसको हम रेजिस्ट उसको कहते हैं फ्रिक्शन या पुल या पुश. या फिर अगर वो रुका हुआ है तो वो मूव तब तक नहीं करेगा जब तक कोई फोर्स नहीं लगाई जाएगी। अगर किसी भी ऑब्जेक्ट का मास ज्यादा है, मोर मास, दैट विल बी इक्वल टू मोर इनर्शिया, मींस हैवी ऑब्जेक्ट इज हार्डर टू स्टार्ट और स्टॉप देन अ लाइट वन। अगर कोई ऑब्जेक्ट भारी है तो उसको स्टार्ट करने के लिए मूवमेंट भी ज्यादा फोर्स लगानी पड़ेगी और उसको रोकने के लिए भी ज्यादा फोर्स लगानी पड़ेगी। Importance in daily life. Knowing about inertia helps us understand and predict how objects behave, and it allows us to design safer systems, tools, and transport. It explains many situations in daily life and helps prevent accidents. Basically, knowing about inertia helps us to stay safe, like by having this concept, we get the importance, we get to know the importance of seat belts in cars, and we design vehicles and machines so they work smoothly on this principle, and we can prevent the accidents by getting the knowledge of inertia. Example: seat belts in cars protects passenger when the car stops suddenly, preventing them from moving forward due to inertia. When cars suddenly stop, if we don't wear the seat belt, our body can fly off the car. Okay, because of the inertia, that body will resist to stop. Okay. Luggage in a bus tends to fall over when the bus stops suddenly because it wants to keep moving. It's same like that. If we don't tie the luggage in the bus, and when bus suddenly stops, that luggage will that luggage is also moving now, so that luggage will also move in that speed, that luggage will resist. ठीक है, so वो हमारे ऊपर आके गिरेगा अगर हम उसको टाई नहीं करेंगे. Shaking a tree branch causes loose fruits or leaves to fall due to their inertia keeps them still while the branch moves. अगर हम किसी ट्री ब्रांच को शेक करेंगे तो उसके ऊपर मौजूद फ्रूट्स या लीव्स वो रेस्ट पोजीशन पे हैं, तो ड्यू टू इनर्शिया वो रेजिस्ट करेंगे, वो मूव नहीं करेंगे ब्रांच के साथ ही, तो वो वो स्टिल रहेंगे और ब्रांचेस मूव करेंगी, इस वजह से वो टूट जाएंगे. Question number 3 is state and prove Newton's second law of motion. We have to give the statement of Newton's second law of motion, then we have to prove that statement. Statement is the acceleration of an object is as produced by a net force is directly proportional to the magnitude of the net force in the same direction the net force, and inversely proportional to the mass of the object. Acceleration of an object is directly proportional to the net force applied and in the same direction as the applied force. Okay, एक्सलरेशन की डायरेक्शन सेम है जिस डायरेक्शन में फोर्स अप्लाई की जाती है, और ये फोर्स के डायरेक्टली प्रोपोर्शनल है, एंड इट इज इनवर्सली प्रोपोर्शनल टू द मास ऑफ दैट ऑब्जेक्ट. मैथमेटिकल फॉर्म: change in momentum, delta p is known as change in momentum over time. Since momentum is p is equal to mv, mass and velocity of that object, so and if that mass is constant, then f will be directly proportional to mass delta v, velocity and time are changing, divided by delta t. And we know that change in velocity of change in the velocity of the object over time is known as acceleration. So f is equal to that force is equal to ma, mass into acceleration, where force is f is equal to force applied in newtons, mass is equal to mass of the object in kg, and acceleration is acceleration produced by that object, which and it has the unit of meter per second square. And proof: momentum of body is equal to p is p is equal to mv. If velocity change from u to v in time t, so change in momentum will be m into in final velocity minus initial velocity. Rate of change of momentum will be same change in momentum divided by t, m into final velocity minus initial velocity. By second law, as we know, force is directly proportional to ma if we choose units so that proportionality constant is 1, force will be equal to ma. Explanation: the greater the force applied, uh, the greater the acceleration produced for the same mass. If the mass remains constant, if we applied the greater force, the acceleration will be greater, and for the same force, a heavier mass accelerates less than a lighter mass. If mass is greater, then and force is constant, then it will accelerate very less as compared to lighter one. For example, a loaded truck needs more force to accelerate than an empty one, and a cricket bowler uses more force to speed up the ball. Okay, next is deduction. Next point is deduction of Newton's first law from Newton's second law. If Newton's second law is if no external force act on the body, then force will be uh, 0. Okay, from F is equal to ma, this gives acceleration. If F is equal to 0, force is equal to, then acceleration will also be 0. 0 acceleration means velocity remains same. Acceleration, as we know, acceleration is equal to delta v over delta t. Therefore, the body either stays at rest or continues moving in a straight line with uniform speed. So in that case, that if velocity remains constant, either that object will be at rest or will move with a continuous same speed and same direction, not direction change or in a speed change or although moving. ठीक है, then velocity will be same. ठीक है, this exactly is the statement of Newton's first law of motion, जिसमें कहा गया था कि if no external force is applied, okay, that object will remain in that state. Okay, examples: a loaded truck needs more force to accelerate than an empty truck because of its greater mass, and a cricket bowler applies a strong force to a ball to get it rapid acceleration. Question number 4. State Newton's third law of motion. Explain with examples from daily life. We have to give the statement of Newton's third law of motion, and we have to give the examples from our daily life as well. Newton's third law of motion states that for every action there is an equal and opposite reaction. This means if body A exerts a force on body B, then body B exerts an equal force in the opposite direction on body A. These forces always occur in pairs, mean every action has a reaction, are equal in magnitude. Force will remain same. हम अगर जितना ज़्यादा एक्शन करेंगे, in return that same magnitude का reaction मिलेगा. Are opposite in direction, act on different bodies so they do not cancel each other. Like मीन डिफरेंट बॉडीज मीन्स हम जैसे अगर किसी चीज़ को पुश करते हैं, ठीक है, तो हम उसके ऊपर एक्शन कर रहे हैं, वो इन रिटर्न हमारे हैंड को जो फोर्स लगाएगा वो उसका ऑब्जेक्ट का रिएक्शन होगा, और वो ऑफ कोर्स हमारे हैंड पे होगा. तो इस दिस दैट्स सो both action and reaction are acting on different bodies. Explanation: when two bodies interact, the force exerted by first body, which is action, causes the second body to exert a reaction force back. The reaction happens at the same time as the action. It is not delayed. Reaction उसी वक्त मिलता है, ये नहीं कि बाद में. Examples from daily life. While walking, you push the road backward with your foot, and the ground pushes you forward with an equal force, allowing you to move. Jumping from a boat. When you jump forward, you push the boat backward. The boat moves in opposite direction due to the reaction force. Firing a gun. The expanding gases push the bullet forward, and the bullet pushes the gun backward, causing recoil. When we shot a bullet, that bullet will move ahead, forward, and that gun will move backward. हाथ को झटका लगता है because of this rule. दैट वो बुलेट जिस फोर्स से आगे थ्रो की जाती है रिएक्शन के तौर पर वो गन को उतनी फोर्स से बैकवर्ड थ्रो करती है. रोइंग अ बोट, द और पुशेस वाटर बैकवर्ड, वो चप्पू के जरिए हम वाटर को बैकवर्ड पुश करते हैं एंड वाटर पुश द बोट फॉरवर्ड moving it ahead. Rocket launch. Exhaust gases are pushed downward and in reaction the rocket is pushed upward into the sky. जब एक रॉकेट ऊपर की तरफ मूव करता है तो वो पीछे से एग्जॉस्ट गैसेस नीचे की तरफ डाउनवर्ड फोर्स से नीचे बाहर निकलती हैं और इन रिटर्न वो रिएक्शन के तौर पे रॉकेट को ऊपर की तरफ अपवर्ड पुश करती हैं. Question number 5 is state the limitations of Newton's law of motion. There are few limitations of Newton's law of motion. We will discuss one by one. Newton's laws are very useful in understanding motion, although, but they are not universal. Means they don't work everywhere. They have certain limitation. Limitation number 1 is applicable only at low speed. They are accurate only when the object speed is much less than the speed of light. At speed close to the speed of light, Einstein's theory of relativity must be used. Means ये स्पीड ऑफ लाइट से कम स्पीड पे काम करते हैं. ठीक है, अगर स्पीड ऑफ लाइट इज इक्वल, अगर ऑब्जेक्ट की स्पीड ऑफ लाइट जितनी है देन आइंस्टाइन रिलेटिविटी यूज होगी. वहाँ पे हमें करेक्ट एक्यूरेटली रीडिंग्स नहीं देंगे न्यूटन्स लॉज. ठीक है, नॉट वैलिड फॉर माइक्रोस्कोपिक पार्टिकल्स. For a particle's atomic or subatomic level, Newton's laws fail. Instead, quantum mechanics describe their motion accurately. Means very smaller particle, microscopic particle जो microscope से नजर आते हैं उनके ऊपर न्यूटन्स लॉ फेल हो जाते हैं. वहाँ पे क्वांटम मैकेनिक्स यूज होती है. ठीक है, assumes mass is constant. Newton's laws assume that mass of body does not change during motion. This is not true for objects like rockets which lose mass as fuel burns. न्यूटन्स के लॉज में यही अज्यूम किया जाता है कि फोर्स इज कांस्टेंट. बट इफ वी टॉक अबाउट रॉकेट्स में तो वो फ्यूल बर्न होके वो फ्यूल ही गैसेस जनरेट करके बैकवर्ड आ रहा होता है ना. तो this law will be failed in case of rocket. Does not consider very strong gravitational force. In extremely strong gravitational field like near black holes, Newton's law are inaccurate. Generally, relativity must be used instead. general relativity वहाँ पे यूज होती है. ठीक है, based on inertial frames of reference. They are valid only in inertial frames, non-accelerating frames. In accelerating or rotating frame, fictitious forces like centrifugal force must be considered. In rotating and accelerated frames, extra fictitious forces appear like centrifugal or centripetal forces. However, Newton's laws are not exact but provided a good approximation on the large scale, microscopic scale, and over the vast range of practical energies and forces. Newton's laws are still work spectacularly well in physics and engineering. For everyday life, engineering enormous speeds, Newton's law work perfectly. जो माइक्रोस्कोपिक ऑब्जेक्ट्स होते हैं और डिफरेंट वाइड रेंज ऑफ एनर्जीज हैं वहाँ पे न्यूटन्स लॉ वर्किंग वेरी इफेक्टिवली एंड efficiently. Okay students, that's all from this lecture. We have now completed long question 1 to 5. Keep revising these solutions and practice writing them in your own words for better exam preparation. If this video helped you, don't forget to like, comment, share and subscribe for more clear and simple physics lectures. See you in next lesson. Allah Hafiz.